Hello, my name is Yvelice Castillo from University of Coimbra, Portugal. I will talk about geomagnetic activity at Northern Hemisphere's mid-latitude observatories. What can be explained with the Tsyganenko and Sitnov 2005, the TS05 model. This model simulates the magnetosphere's transient signal during geomagnetic storms, from Earth's surface up to 20 Earth radius. Data used as input came from 6 spacecrafts located from 2.5 to 20 Earth radius. The model separates the magnetosphere signal into 6 current systems. The INT, that is the penetration of the interplanetary magnetic field into the magnetosphere. The CF, the Chapman-Ferraro or magnetopause current. The tail or cross-tail current field. The PRC, the partial ring current. The SRC or symmetric ring current, and the FAC or field-aligned current system. Data from 4 magnetic observatories at similar geomagnetic latitudes were used and were compared with TS05 total field and with the 6 current fields. These stations are Coimbra, COI in Portugal, Panagurishte, PAC in Bulgaria, Novosibirsk in Russia, and Boulder, both in USA. We selected as active days those with at least 1 K local index greater than equal 4. We used Pearson's correlation coefficients R to measure how well the transient signal is modeled by the TS05 total field and by the 6 current fields. We can see at the panel at the middle top the correlation coefficients of the 6 current systems. It is clear that tail, SRC, and PRC are dominant for the X component, and the FAC and PRC are dominant for the Y component. At the top right panel, we can see a plot of the TS05 model, total field in blue, data in red, and a TS05 plus a linear regression fit, the TS05R, in green. It is interesting that the scale parameter in the linear regression fit is in agreement with estimations of the induced fields with better values for X than for Y. And also, the chief parameter of the linear regression is in agreement or is in the order of the cross-tail biases, with better values for X than for Y. The left bottom panel shows amplitude coefficients. They are normalized in order that the TS05 total amplitude is equal to the sum of the amplitudes of the currents. It is clear here that for the X component, the tail and SRC system is dominant at the 4 observatories. For the Y component, the tail, SRC, PRC, and FAC have similar values for COI and PAC. For Novosibirsk and Boulder, PRC and FAC are dominant for the Y component. At the bottom middle panel, we can see 4 examples, both for the X and for the Y component, for COI and Boulder, of storms during active days with R greater than equal 0.7. TS05 total field is shown as a black continuous line. The data fit to the TS05 total field as black dot line and the currents in colors. In conclusion, TS05 model simulates better the X than the Y component, with 50% of active days for X and 30% of active days for Y, with correlation coefficients greater than equal 0.7. Thank you very much.